I love the Wings channel. Boy, if I didn't have the Wings channel, I think I'd go crazy. I look at myself, all these windy videos all day. Anyway, we're back to working on the B-25, of course. On the last tape, we skinned the wings, cut the wings, set the house on fire, had a great Christmas. Did several other little projects relating to the B-25, but here we are. These have sat overnight now, and one by one we can take each panel apart, carve and sand the leading and trailing edges in, get them ready. We also, because of this dihedral brake, the multiple dihedral brakes, we're going to spend some time figuring out exactly how we want to do that. But the parts of this that are going to make sense if you're just making an ordinary foam wing model would be just joining the two skins, getting them perfectly level in the cores, and of course it's relatively simple relative to putting dihedral brakes in. How we're going to mount the control system, the way we're going to glass the middle of the wing, it's all going to be applicable to other than B-25 type stunt ships. Secondary project is going to be, and if time allows and when it's available, we're going to be carving up all the blocks. Elliot Scott brought us these blocks from England. They're excellent, really super light wood. We're going to be working off a center line. We have the crutch already framed out. Our lowest priority thing, we have clear drying on this probably for quite a while now. It's probably we could stop and take a day and sand it and buff it and whatever, but we need more clear on there. And having several projects to work on at once is going to give us the luxury of not being bored, where if you're working on the same thing over and over and over, I tend to get bored anyway. So the first thing I want to do is take one of these panels apart, set one up on video to getting the leading and trailing edges carved, and we'll move on to whatever the next, in whatever logical sequence, because I've been thinking about exactly how I want to do these operations. Again, this airplane is so unique relative to other planes I've built that every step of the way I have to be thinking about what I'm going to do next, what's going to be next, how am I going to do that, and that is absolutely the challenge that makes this so much fun. Just having something totally different that you know you're not going to show up. Actually, you're not going to show up in the history of the event. I don't think anybody's done one of these, so we don't have to worry about somebody coming digging up a magazine that somebody had a B-25 from 200 years ago or something in the Stone Ages. Anyway, but this is for sure, to set the stage here, for sure, keeping my mind occupied 24 hours a day. You're joining two panels, and we're getting ready to do this. This is something that's very easy to do. Is when you have a sanding block and you're sanding these edges. Well, the ones on the wingtip, if the wingtips are 1 degree off, it doesn't really matter. It's not really critical. But what is critical, even on a cardinal or a traditional plane, is maintaining that these two angles are identical. Because you want to reference off, and in our case this is not the case. I'm just laying this out to show how complex this is. This we want to have on a traditional model. You're making a cardinal, you're making an impact, you're making an SV11. You want this line to be straight, and you want these two lines to be 90 degrees. If one of these is off, well then what happens? This trailing edge becomes, I'm overdoing it here, a V. Well, you don't want that either. So I have to make up, when I'm sanding these edges and carving my edges in, that's the #1 priority. Now, because in our case we're going to be making another joint out here, and we have this swept forward trailing edge we have to work off, maintaining equal angles at every joint is going to be a real critical thing, and that's going to be one of the challenges of getting this wing put together, is not only the dihedral brakes, but keeping these angles all so that this angle going up the fuselage and this one, that we don't have any of these on an angle that's going to create some kind of funny aerodynamics for us. Real lucky is we always have the reference lines that when John actually cut the wing, there's 3 holes in each wing that held a template. We can always reference our center line off of that, and what we're going to try to do is on all of the things is use both of our center lines So as we set up dihedral brakes and the like, but if you weren't doing dihedral brakes even, you'd want to line up both center lines. You wouldn't want to have one wing down, one wing up, or one wing bow down. So what I'm trying to explain is this is to get all of these angles right at the same time. A little bit complex, but it's no more or less effort than if you were building a built-up wing. You'd still need to maintain everything at 90 degrees. Just that this having these reference points, again, it's these reference points, and if you have a triple core wing, well, it doesn't really matter. If you have our wing this is called triple coring, but we have reference lines. The more you have, the better. And always, somehow, as soon as possible, and we'll be doing that as soon as we sand the edges of this clear, we're going to make sure we scribe in a center line. Now, one of the advantages of doing a foam wing, it's real easy to keep track of where that center line is. Another way to do it, maybe we'll even do this, is to, when you're all done with this, insert a toothpick, glue it right in, let it stick out a little bit, and then sand it off. So that at any given time, if you're looking from the wing from the front and you want to find that center line, it'll be the wood toothpick, and then you can line up. You have a reference to do the lineup. Again, lining this up and thinking how we want to go about doing it, that's part of the fun, and that's part of what makes this a fun project. The way to go about this that makes sense is assuming you have, this is a traditional wing, you have a flat table, and of course this assumes that table is perfectly flat. If you're using your knee, well, it's not going to work. And using the cores, now John has marked, and most good foam cutters mark the cores, so you're always putting the same core back into the same slot. You can use the cores as a cradle to line these two edges up. And if they're not right, you can block sand them, dress them off until they meet. In other words, if they don't meet exactly, you can sand this one to this or this one until it's a nice even match. And use the cradles themselves as a fixture for joining that wing. Now, the problem is we can't do that because all our joints are going to have angles in them. So we're going to need to come up with a more sophisticated way of doing it. And to tell you the truth, I haven't finalized that plan yet. One common mistake to avoid with foam wings too. You build a foam wing, and a lot of people do this. They lay in like a 1-inch piece of fiberglass down here, epoxy it in, and that's their center support. Well, in this case, what happens is we're going to have, even if that were the case, on a twin-engine plane, you have the weight of the nacelles and the motors out on the wing. So it's creating more of a span load in maneuvers, especially on the G-forces. So what we're going to try to do, and actually the wing joints are way out here, is we're going to, of course, put a joint, glass front to back over that joint. But I'm assuming what I'm going to do, and again, this is the fun to figure this out, is I'm going to glass this whole area from maybe an inch out on each span, and I'll figure this out as we go. Before I put the nacelles on the wing, because then the nacelles will have something rigid to bolt to instead of, because otherwise you're really in essence just bolting the motor to 16th balsa and foam. Well, and I'll, in the way that we've always done it in the past, I'll obviously include some kind of high point ellipses on here for strength, possibly run the ellipses out here. Again, I'm going to have to look at this. What I'm trying to make the point here is that a lot of these things are not the standard way you would do a model, so they take a lot more time, a lot more energy, but it's always that creative, inventive thing that allows you to have a model basically that nobody else will have, or that nobody else has ever had. And that's kind of special to me. I want to make one final thing here before we get down to the shop and start working. Dihedral brakes. You would think, if you have two wings, and let's just make an example of two foam cores, and you want to put dihedral in them, even if it's a simple dihedral like a P51 would be, that what you would do is just cut one of these down the amount it would take. You could do it in one core and join the two together. Well, that's not really true because the two profiles don't match up. The way you get them to match up is when you want to make a dihedral brake. It's like making a motorcycle frame with fish scale cuts, is you have to take the same amount out of each side, and then the two profiles match up. So this is not a good choice. This is the choice that we're going to have to use. This is the way we're going to have to do each piece, is we're going to have to set up on our flat table exactly what half of that angle is going to be, and then with some kind of a sanding block, and again, this is the fun, and I wanted to run all this by because I have nights to think about this. But now if I have sandpaper glued to the sanding block at exactly 90 degrees, I can make this angle when the wing is on an angle, and I can estimate this angle from Dave Downey if I have the drawing. I can cut off that last little bit of material, but I have to do it to both sides equally. Both of these angles have to match, or else I'm not going to get an exact match when I set the dihedral angles. So this is just one of the things. Now it may be the day will come you'd like to make a P51 or something that has dihedral. Well, this is one of the concerns you have to have. The other concern, of course, is, and we're going to get into that on a separate tape far down the road, is the control system. A dihedral brake control system has a lot of little things you have to work around. You just can't bolt in an 1/8 inch horn and go fly the plane. We're going to get to that later. For now, we're going to go work on those wings. It looks like we're going to have a couple hours here before the New Year's party starts, but we want to get... See, there's another thing, too. Time management. Anytime I can steal an hour here, an hour here, an hour here, we were going to have company this morning. They never showed up. I wind up getting a couple hours to work in the shop. Well, some of the other things we had thought about doing, well, what can I do now? Now I have only about an hour, hour and a half. Well, when I have a small amount of time, I look for a job that I can start and finish in that time window. So I at least get something. I wouldn't want to start a big job. I wouldn't want to start carving a block for the top block. Yeah. But I can always take one panel and dress off the wing skins. And I may get 2 or 3 of them done. You never know. Now, the first thing, of course, because these have been drying, there's no chance the glue isn't dry, is there? Take off the tape. And by the way, this blue tape, which I buy at, I think I got this at Home Depot, I'm not sure. It's ordinary painter's tape. It's good for this kind of a thing where you know you're going to want to take the tape off. And see, it doesn't take a whole lot of the material off with it. Now, even a simple thing like this, like taking the tape off, I don't want to gouge up. I don't want to be careless here, because I have a limited amount of time, and whenever I do, I tend to rush. That's another thing. I tend to rush. And what I'd really like to do, I mean, at this point, there's no part of this plane that's under a time constraint that, I mean, we're not going to war with Hitler or something where we have to have this done. What I'm trying to do is build it to a quality standard, and this was a point Doug Benedetti was making to somebody else, is not to build toward a time standard, but toward a quality standard. I think that's really a significant thing. Now, with one side off, you can see the glue joint is almost invisible. There's almost no glue showing there. The pressure of keeping this compressed really is excellent in terms of not having a glue joint that's going to be a difficult thing to deal with when we sand this out. Tip 1, in case you've not experienced it, from this point on we can't get any CA near the foam. The CA, except for the brands that say they don't melt CA, they don't melt foam, and I haven't found those to be my first choice anyway. But from this point on, if I have to reglue a joint, I can't use CA. One of these things has a little sequence that seems to work well for me. I want to cut off all the extra wood here, leaving just maybe a 1/16 of an inch arm. Can zona saw off that piece, but I'm going to leave that little bit on. Zona saw off all the extra edges. And what this last little bit now, what happens if you try to trim this with a knife that's not real, a razor, anything that's not real sharp, the glue tends to build up on the blade. Let me just show this. Because what will happen is, somebody will not realize this, and what happens is the glue builds up, because you don't forget, you still have some spray glue out there, if we could chew some of that off, even though it's dry. Even after a week of drying, a couple of days, it's still chewing gummy. But what happens, then it tears a piece of the wood out right into the core itself. So we want to do the last little bit with a sanding block, and for sure up here, if you try to cut this, what tends to happen when you cut it is it chunks out, and we don't want it to chunk out. So the first thing would be to get this nice and smooth with a nice any kind of zona saw. In this case here, we need to take a very small amount of material away, and the best way I know of to do this, there's a good way for, and I think I'm going to use it. One of the ways that always seems to work well is get a piece of masking tape laid up on the skin itself. Remember, what we're trying not to do is make the skins any thinner than they are. Now I can kind of, it's difficult to do this looking through a lens cap. I'll probably chop my finger off, but I can carefully, and I'm trying to follow that airfoil in. Oops. I can use the edge of a table. Edge of a table is good. Again, I want to take small amounts off. The knife is never 90 degrees. The knife is always 45 or more. Even the more the better in this case. Just taking those last razor little slices off. A brand new blade, needless to say. Now I'm going to work my way down there until I have that angle perfectly cut in. The tape is a good thing because it doesn't let you get down and get too close to the wood. That one edge, now I can do is just flip the tape, or just put another piece of tape on here and work on the other edge, but I want them both to taper down equally here. And of course I can always reference, I left plenty of material here, I can always reference my center line and see this side's getting bigger than this side. I don't even have a center line on here yet because this is still at the rough stage of trying to get this roughed out. Roughing these edges out is, just a little time consuming, but I want to be very careful because if I cut into the wing and put a chunk out of the wing, well, I'm basically going to have either an ugly repair or some unnecessary weight or something. You can see how nice the center line. And by the way, I always keep the cores in while I'm working on it. Even these last little few slivers, I can look at that I get. Now this is still oversized, and I want to leave it oversized. I want to leave the tape on there, let it just be in rough form. Now I'll do the same thing up in the front. I'll lay a piece of tape on here, basically repeat the same thing, just get the rough angles in. And with the tape as a little protector, just makes this a little bit easier. Anything you can do to avoid making a problem. I say that only because I've done it already. I like to leave these pieces plenty big, so this part of it is just simply a carving operation. And by the way, all during the carving operation, needless to say, the cores are in place just to give it some stability. Again, now as I get down, and I'll work my way up, as I get down to the last little bit, I'm trying to use the wing itself, the airfoil itself, as one of the guides. In other words, I don't want to have that shape. I want to have just kind of mirror that and leave that last little bit for the sanding block. And see, I've almost got that in there. Now that's about as close as I'd like to get. Now I can start working my way up. And eventually I have one whole side. I'll have carried that contour right down. I've got half of it carved. I've left just enough up here, a little extra by the tape. Now I'm just going to flip it over and do the same thing on the bottom. So eventually I'll have the same contour that's here and the same rough contour here. Now you can see in this we've got both of these, just a little bit of extra material, and next thing I'm going to get a sanding block with a fresh piece of sandpaper, and from that tape blend that right down. Now with that extra little bit of wood on there, I can just blend this right up to the tape. I'm not gonna touch that flat spot. Just gonna work on this joint. That tape gives me a little safety margin here that I've not thinned out that sheeting any more than I want to. Now you just carry that curve right down. You can see once you pick the tape up, and you can see we've got a pretty nice one. We still have a little bit of material there because we don't have the center line on here yet, and I don't want to put the final curve in there till we have a center line. But that gives me enough. I've got all the rough work done now. And I'll just repeat the same thing on the trailing edge off camera. We're just going to have just the thickness of the tape on both sides. Now the last little bit of this, of course I have a little bit of a lip, the final tuning to do. I want to make sure all the cores are in. And just sand off right up to the foam. Not into the foam. I don't want to change those angles. So I just have to monitor that I'm getting up close to it. Take a few more swipes. I need to pick up these center line parts, the markers. There's one on each end. And continue that center line out onto the edges. Now with that center line on both sides, now I can bring it around the front and just carefully put a little niche here. Same thing on this side, just continue it around. Then from those two center lines, I can connect them with a center line front and back. To do is hold, just let a piece of tape hold it both sides, again because I'm working alone here, I don't have somebody around to do my center lines, and then go right up to the tape, because even if your hand moves just a little bit, and before we put that last little curve on, we certainly want to have that center line. Because from this point on, everything is going to reference off that center line. Now that I have that center line on there, now you can see I'm missing the two little spots. It won't matter. Now it's a matter of very little effort. Almost like connect the dots to just go where the tape was. Now, with that center line, now the last little bit, you just go over to the sanding bench and radius that front off, and the same in the back. See, another way of doing this, of course, if you have an inclination to use a plane. Now, at some point in time, because we made these oversized, we're going to take that leading edge off. But because we have the marks, when we're all done putting it, we can get it right back. And as I'm doing this, I'm just working that leading edge in. A lot of times you can feel it with your hand. Again, if you're using a plane, hold it at a 45-degree angle, a wood carving plane. Clear the chip here. But then, equal amounts off the top, equal off the bottom, and the last little bit we'll do with a sanding block. And this is how we get accuracy to get that center line. This is the single most important thing we're working with, especially on this dihedral wing. We don't want to lose that center line. And we're going to be making up a little template, of course, but I just want to see if we're close to having the radius that is called for on this airfoil. It looks like we're real close. But what I'll do just to make sure is I'll make a little gauge out of maybe light ply or something, or balsa wood, so that I can then go up against this and see exactly. I want to get that radius very accurate. Now, of course, by the time we got to that, we've sanded off and totally lost the center line again, but because we have these two reference lines, we'll just connect it again. Right off of the drawing, we're going to make, I cut up the spare piece, and I'm going to Dremel saw that real accurately, because that's going to be my leading edge radius gauge that I can maintain a good, an accurate from Dave's drawing, of course. Just the roughest of gauges, and it's just meant to, we're only working on the wood part, obviously we can't change here. So from here to here, it'll give us a rough gauge if we've gotten it different than the plan, and I'll make one for each station, so I can, and then hopefully maintain accurately the radius that Dave has called for in his plans. A little bit of this sanding. I have my gauge. And I can just see where the high spot is. I can lay it right in the core and turn my vacuum bench on. And the last little bit. That last little bit where the tape was and that glue joint. Now once this is done, I'll do the trailing edge exactly the same. Put the center lines back on this, and we've got one section done. And that's probably all we're going to get done in this section. This session, I should say. But even though we only had a short amount of time today, every time we can get one little thing done, we get a little bit ahead on our production schedule. Now, needless to say, I'll do the same thing in the back. It's not a whole lot different. I have to take off the thickness of a piece of tape, really. Put a radius on there. And then the final thing, just hit the glue joints. Again, the main objective here is not to thin the skins too much. I don't want to skin them by a minimum amount. I don't want to thin them out because the nacelles, it's a little bit different than a typical single engine plane. That center section of the wing needs to be a lot stronger. This final thing, and this is going to be all I'm going to get to do in this session, is take a piece of sandpaper, and whatever you want to call this action, shoe polishing or whatever, just very gently. What this does, if there's any high spots that I've missed, we got both edges pretty nicely dressed in. The only thing left, we got to re-put on our center lines. We have all our radiuses real nice now. And that's one section done. So the first of our, I'm going to make a little correction there. First of our panels is done. It's a good feeling to know it's done too. And so, even in this little time, we get a little shop session here, a little shop session there, and all of a sudden, some more parts are done. Today, as I'm sanding out the end of each piece, what I'm trying to do is make sure, and I'll try to get this up on camera, that I have a real nice joint. Even though we're going to put dihedral in there, now if we weren't going to put dihedral, of course, then I'd be checking with the cores to make sure I have this all 90 degrees. But this looks really, really accurate right now. Again, this is a part of, I have to put the center lines on here too. Again, part of this is how accurately John cuts the cores. Another part is that we don't change it when we're running a sanding block on it. We just want to kiss the foam, but not put a bow in it. Now I'm working the two center sections first, then I'm going to work the two end sections, but I hope by the end of this day I'll have all four of these sections sanded out, and all the joints where two come together. Of course, on a traditional stunt ship you'd only have the one in the middle, but to get a really perfect fit there before we go any further. Okay, now that we have two panels done, we can start to see what the wing is going to look like when it's all assembled. Kind of getting a little motivated here, and I'm going to go like put a little bit of a push on, because I'd like to finish these two outer panels and get the whole wing laid together in one piece before the session's over. Now how I tend to do this is whenever I take a coffee break in between parts, just kind of look at it from a lot of different angles. The swept forward trailing edge, and this thing has the little dihedral brakes in it. I don't know. It's going to be a pretty cool looking wing as far as I'm concerned. And I guess some people, you know, worth mentioning, some people don't think any of this is worthwhile. Just build up a normal traditional stunt ship and every year paint the leading edge a different color or something, or change a quarter of an inch on the rudder or whatever. Well, I don't, that's my personal thing, is I don't find that real challenging. But boy, I sure do find this challenging. This kind of a project that keeps you awake at night. Keeps you young, at least it should. How come it isn't working for me then? Now what's really saving us a lot of time is the fits on this are a lot better than I expected them to be, and that'll help when we go to grind in the the dihedral joints, which is going to be one of the next steps. And I haven't decided yet, of course. I've been thinking about it all day. Do I want to join these two pieces and these two and then join the middle? Or do I want to join the middle, get the bell crank in, and then... So you got a lot of choices here. But anyway, it's just one of the things I can be thinking about. I have one more panel to go. And then I can kind of stand back, look at this in full scale. I can actually, what I can do is compare it to that Miss Ashley wing, just to get a rough idea, a rough look at it. Handy that we have a spare wing that's not attached to a plane here. Anyway, it just goes a little quicker. Each panel goes a little quicker than the one before, and we're only one panel away, so we want to get this over with. Well, we finished this session by having all the panels sanded out. All the joints match relatively well. Next time we get to work on this, we're going to try to set up, and I decided to do the center first, set up that dihedral angle, and what we'll have to do is measure off Dave's drawing and make some kind of a little gizmo that can hold it in position while the bell crank is drying in place, and well, I thought of how many other ways I could do this. I think doing that center section first, that'll be the easiest way. I'll have to make up a couple of jigs and tools or whatever. I'm not sure yet. Give me some time to think about it tonight. Now what I want to do right now, I want to confirm that, this is really just to confirm, I got these up on a gram scale, that, and of course, it's a good idea to do it with the coring pieces out. Now the reason I'm weighing these is I just want to confirm that I have the two heaviest ones on the outside. Now in the case of doing a traditional stunt plane, it would, and by the way, I want to put these back for the time being, just while we're storing the wing and handling it and whatnot. And there was a time, there's a funny story, there was a time I was trying to figure out which was the heavy wing and which was the light wing on one of the foam ships, and I inadvertently didn't remove the cores on one. I said, oh, there's the upward wing. Oh man, it's not even close. Now in this case, we know we used the lightest skins on what was what may still be, who knows. Let's see how close these are. Now for us, it's within 3/4 of a gram. So I'll write it down anyway, but on a traditional ship you would want to weigh each panel, and possibly that would save a little tip weight or whatever, or you just know that you're doing a better job. But that's a true story. It took me a while to figure out, gee, that wing isn't really that light, it's just that I weighed the other one with the cores, and oh, it adds a couple of grams. Anyway, they're within a gram of each other, less than a gram. Panel and the outer panel, each one is 55 grams on the two heavy ones. Well, one's 55, one's 56. But I always used to think when you're doing a traditional, like a cardinal wing, a good weight is between 110 and 112 grams. Well, you could figure out if this was a cardinal wing, or if it was in one piece. And this is roughly, it's a little bit bigger. So what it's telling us is we have a pretty good weight here. We don't have extra glue or something that might be a problem on the final plane. Next thing is to figure out exactly what these angles are, and one of the things I have is the drawing that Dave originally made here. I'm just going to mark this with a highlighter for myself because I'm working off center lines and I can see his line through my line. I only need to figure this out once. This is the actual center line that he's figured out. And believe me, you don't see it on a video, but Dave has spent a lot of hours and we've done a lot of phone time figuring out how much of this, how unscale we could make it. So we have a center line. Now I have to figure out what the difference is, referencing off, and I noticed the drawing is on a square sheet of paper, referencing of what the dimension is. I'm only concerned with the variance between the tip. I'm not concerned with, is this one 2 1/4, 2 1/8, or whatever. It's how much different is it, so I can put these first two pieces on the angle I need to, and then sand in the dihedral break. And this is where it gets a little, well, relatively complicated. Now, from the center line, and this gets a little tricky, it's an inch, an inch, so each side has to go up a 1/2 inch. But then where this line goes, the center line is straight, but because the wing tapers, it appears to have a little bit of a droop, and the droop is exactly the amount that the wing tapers. So I'm just looking at how many choices I have here. I need to make up a fixture and a block that I can get exactly a 1/2 inch up on each side, and then make a parallel cut on this side, a parallel cut on the same core. I want to make as much of the cuts on the center core as possible. So it's relatively easy to figure out what I have to do. It's a nice even number. It's a 1/2 inch on each side, and the other two sides will have the amount of taper, and I'll have to make up a little piece here. I'll have to figure out exactly how much they taper down, but that's going to make it, well, not make it easy, none of this is easy, but make it that it's at least doable. So we know the two center pieces, before I can mount the belt crank, before I can do anything, I've got to make the angle cuts that each side of the center cut is a 1/2 inch up. And I want to take the same amount off both sides, otherwise this joint would be off on an angle. Now before I even start this, I like to visualize how these things are going to look, and I always find a concept drawing. It takes about 10 minutes for me to do one of these with colored pens, and I can visualize now a lot better what this is going to look like. That angle of droop is going to be, again, it's going to be half of the difference between here and here. But I've gone through this so many times in my mind that the first thing I want to for sure do is set up a little fixture and a sanding block so I can sand in these two angles. And by looking at this, now in this case I need to take this angle out, but then when I set this one up, I'm going to have to, in essence, come so that what will ultimately happen, all the joints will be at exactly 90 degrees to the ground. So that's what I'm trying to set up here in my mind. Again, I don't do this every day. What I do is answer the phone every day, so let me see what's going on. Now before I actually make this up, I had to conceptualize it, and I thought I have these giant blocks of balsa wood, and what I could do is glue some sandpaper on one side, make sure that this is 90 degrees, and now the thing to remember when you set a dihedral angle is you just can't jack this end of the foam core up or the wing. You have to be on center. So I need to figure out what the root is, then the secondary, the root that's at the break, deduct this amount from, you see what I'm saying? I'm not deduct it, I have to add it. See, this is what happens when you work late at night. So what I ultimately want to wind up with, and I'll measure it, is that the center line here and the center line out at this end, there's a 1/2 inch of dihedral in that break. Now the other part of this, and I haven't figured out exactly how to do this, I'm working off a table, and what I thought I'd do is measure up a 90-degree angle and make a little fixture. This is looking from the top, from some of the 1-inch blocks we have, that this could sit in. And then what I can do is, by using this block right here, that would give me this angle, because again, I don't want to change this angle either. This is a little more complicated than what I first thought it would be, but I hope I've taken everything into account. and most important, that we get half of the amount off of each block. When we're done, that we have a good joint, and then I also at the same time can do this end of the block, because what that'll set, that sets this wing in position, and then all I deal with is the taper. The taper should be pretty close. I just maybe a couple of swipes of the sandpaper. So what it boils down to is getting this, both sides of this done accurately right now. And then what I'm going to do now is try to make up a fixture that'll help me do that. We'll start by working off a 90-degree edge to the table just to give me some kind of reference line. Now, a 1/2 inch. The core takes into account the amount the root changes. The 1/2 inch gives me the center line, but I'll double check it, of course, anyway. Now what I'm going to do is I'm just going to tack this, all of these pieces of wood I'm going to tack down to the glass table, which is flat. This is my 90-degree line, and so I'll make a little, like a box with 1-inch wood that I can, or some scrap wood, doesn't matter what kind, just to hold the core in position while I'm sanding this angle. And you can see what that angle will be. It's favoring this way now, but I'll be able to get that side, and then I'll be able to come up here on this piece of wood and dress that off. And what I might have to do is take a 1/16 of an inch or a 1/4 of an inch off of this core so that the part sticks out on both sides at the same time. But having one of these cores, and I also thought another thing, I could, if this isn't solid enough, and I think it will be, I can glue a piece of 16th plywood or something to the bottom of it so I have a solid container to hold this while I cut that dihedral angle. And this is one of the things that really was tweaking my mind, trying to let me think of how I was possibly going to do this. And if you get this wrong, a lot of other things are going to be wrong. So I really want to make sure this is as accurate as I can make it. And again, if you were doing a Mustang and you just wanted to have one dihedral angle, you'd only need to do this once. The time you get into doing invent-it-yourself stuff or new stuff, or there's two things. It's very frustrating because you always leave out one step that you said, oh, I forgot. Well, I'm trying not to do that, of course. Now you can see what I've already done. First thing I did, I put it in, I realized I need to cut some away. And since I don't need the cores after I join this, I'm basically done with this now. Tape that in position, and this piece will ride up. I have a little detent on there. I can put the foam out this way for now. And what it's going to do, hopefully, now it's good and solid here. I can move the whole table. But it holds it in position while I'm running a sanding block that has a 90-degree edge. I can then have two choices. I can reverse it, or I can come up here with the same sanding block and see if that's going to be practical. I don't know if it is, but again, if this was all cut and dry and easy, well, everybody'd be, you'd all be out flying today. Instead, this is what I think will be a good way to do any plane that I want to have a dihedral brake and a foam wing on, because this takes into account the trailing edge sweep, the leading edge sweep. All my angles will be 90 degrees to the ground, and when I'm done with this, the wings that attach to this side already have a 90-degree cut in them. I just need to measure to make sure I haven't got more taper in one, that one isn't drooping down more than the other. So a good starting point. This is really a big step forward, knowing that I have this part done. Now, needless to say, you've got to make sure that it's the outer wing that has this angle. I've already thought that through. And what if you put no. So we're going to do the outer wing first. I want to make sure this has the right angle and everything in it. Kick out of this as I'm outer. See, so we've already caught ourselves making a mistake. But if there was no chance you'd make a mistake, hey, if you edit all this stuff out, then the person watching the video doesn't come up with any brilliant ideas either. Okay, so the first thing we have to is use the right core. Kind of a thing that the carpenters use is measure twice and cut once. Well, if you're doing this kind of stuff, I guess you've got to measure several times. Now we've quadruple checked that that it's the right core. Too many things going on in my life here. Okay, it's the outer core. That's going to marry to that side. Now what I'll do just for my own my own little reference, I'm just putting the slightest little dot on each side. That's the side that's going to be facing up. Now I need to make up the tool that's going to do the cutting here. I need to find a sanding block that I can glue rough sandpaper to one side. And the widest, biggest block, the bigger the block is, the better. Even a 2x4 would be fine. And I just want to double check this. Because otherwise what happens, you start sanding, and if you're not careful, you do this, you change that angle. So I'm going to have to make some kind of a reference here. Maybe I'll just tape the ruler down so I can monitor that I'm not going off to one. See, that lets me check that side. And it may look like it takes a long time to make up a fixture like that. It doesn't. It's only 10 minutes. But it really gives you a real good shot at getting this real accurate and get all the center lines on center. And once this centerpiece is done, I think we've got the hardest part of this wing done. I found this really old. I've used this several other times for a part of a tool. You do that epoxy all over it. So I'll pick the straightest side. And this side looks okay. Just pick a side that I know. Try to dress this back off to where it has at least one flat side and one side I can reference off at 90 degrees. Because I need to check, most of all, that this angle in here is 90 degrees. And if it isn't, I got about 10 of these blocks. If this one doesn't have a 90-degree angle, we'll find one that does. If I look down here, you can see one of the things that's wrong with this block. See, it's not 90 degrees. If you can see that. And there's really, once one angle is off, I really need two angles to be, and that one's not good either. So, back to the wood pile. I need a block that one end, because one end's going to ride on the table, one end's going to do the cutting. So, back to the wood pile. Now, miracle of miracles, looks like we have one here. I guess it's how they cut it. This is not exactly on that corner. This is going to be close enough on this side. This is the best one we got. This angle here is exactly 90. This is the angle, and you can see it's because this is the way the tree grain grows. This is our good angle here. And on my 90-degree angle. This is going to be the sandpaper side. I'm not sure. I'm going to use 220 paper. I'm not sure this is going to stick as well as it has to. But if it doesn't, what I'll have the choice of doing is, of course, a sticky back paper. The thing that I'll do then, let's see if I can, maybe by putting this back here, it'll serve some useful purpose. I can trim that edge. Yeah, it looks like it's going to hold well enough, but if it doesn't, the choice that I'll have is to make this sanding block up with possibly with some contact cement on there. Sometimes this sticky back paper, depending on the wood, doesn't really want to stick. Now let's just take a little rifle cut here. I need to get this, because you can see how critical this is. This is not like just take a swipe and you're done. This piece can't move, and I'm looking from the top to see I'm not putting this angle in or this angle. Just doing this by hand, actually. Let me do this one more time from this angle so you can see what, once you get that angle just off, and it doesn't take much. If you look down here, you can see how much of an angle, and it looks like, you can't really tell, probably a 1/16 of an inch. But I need to make this cut and keep working on it, and what I'll do is I'll draw a little line on there so I can see. The line is going to help me just keep taking ice shavings off the top as that block walks in to where it's one true surface. seems to be holding it in pretty good location. I put a little handle on here just to make it easy, just tack glue that on. And we'll save that block until we're finished with the plane. Who knows what we're going to be using it for. But you can see just getting that exact, so there isn't even a pencil line in there. Very critical. What I did, just to give me a little reference line. The only reason for that tape is so I can see if I'm walking off one side or the other as I'm grinding away here. Now the material comes off relatively quickly, so I don't want to go any further. I don't want to turn this, take a ½ inch span off either. But this should give me a real nice cut on the whole part at one time. Now it looks like this is going to work just fine. I just need to keep going until I know I have the whole part. I have a 90-degree flat face I'm working off. Things you can do because we really can't see the other side, I can just put a couple of dots on here. And when these are all removed, it's that side that we're concerned with for right now. When that gets removed, we know we have a pretty good. This should give us some real good integrity. Now we got quite a bit more to go. Should give us some good integrity in that middle joint. I don't want to have that joint all filled with glue joints and everything. That center joint is going to be taking a lot of, the two nacelles are hanging out there in 15G turns. The torque of the motor is pulling. Normally the motor is pulling on the fuselage. In this case it's pulling on the wing, trying to pull the two wing halves apart. Okay, the first two are gone. Now we can just fine tune this in for that last little bit. And then what we have to do is reverse the whole fixture so we can do the other side. Just put it on a table, on the other side of the table. Take 2 minutes. This really ensures that we're going to get this as accurate as possible. In fact, what I thought about doing, it might be a good idea, maybe I should even think about this, is just making another fixture so I can, if I go to join these together, I can put it back in a fixture and dress it off. So these are the things you think of. Okay, 2 to go. 2 little dots on the bottom. 1 dot coming down the home stretch here. No dots. And do we have it? It looks like we're real good. I'll be curious to hear if Dave Downey approves of this method or if he says, Wendy, you don't know anything about stunt. Now I need to reverse the jig. I don't have enough patience here to make up another one. This one is fine. I'm going to reverse this so that in essence, no, before I do that, see, you get ahead of yourself. I need to dress this edge off just a little bit too. I'll put down another piece of ½ inch wood so I have the equivalent of a table to work off there. But so that looks like it's going to work fine. That looks like it's going to work okay. It only takes a few minutes to make, and I think it'll be relatively accurate when I'm done. This will be an accurate cut. Is a little more difficult to, because the holding this in place is a problem. And I'm not sure now because this angle is going to be 90 degrees coming this way. This joint might have to go halfway. I don't know if we're going to have to fine tune this joint. Again, we can figure out how to do that if we have to, but having them all at 90 degrees to start with. That should in essence give us half of the dimensions we need. And if it doesn't, we'll have to adjust the jig or make some other accommodation to that. Now I need to reverse, I'll do this off camera, reverse everything to the mirror image and make sure I'm not making two left sides or whatever, which I've already, excuse me, almost fell into that trap. Reverse the jig for this angle, I can move it all over to the other side of the table. And when these join, that joint should be 90 degrees. Fixture, I just keep this in my scrap bin. The little piece that sticks to the glass table, get that up. Now if we were going to make 6 or 7 of these models, I'd make a permanent fixture on a, a more permanent nature, but this, I think, is going to work. Again, I'm looking for a lot of feedback from Dave Downey, who, I guess Boeing's budget on these projects is a tad more than mine. Mine is usually, this is my budget. But this reversed, again, that thing of making two left sides or right side, I'm sure everybody's done that. But this jig worked out really well. We'll find out as soon as we go to join these parts together how well it worked out. And what I've been doing is putting little dots along the whole perimeter. When all the dots are gone, I know I've got a flat surface. It's easier to go this way because you're pushing into the jig. Actually, if you really wanted to, you could just glue a block here so that you had a support that way. Again, that's the stuff you got to figure out along the way. Just on the wood, I don't really care about the foam. When I get down to that final cut, I don't want to put a whole ink marker on there, but just enough. You can see at some point, well, we still have on the bottom, but at some point in time they start to disappear. And when they're all gone, got almost all of the little orange dots off of this side, and I'm taking one swipe at a time. Just put such a nice angle on it. Actually, I was just thinking of something you could do if you were going to do a traditional wing. You could set up a jig to hold the wing at 90 degrees and dress both edges off. That would really make making that center joint really nice. Now once I take this out of the fixture and clean up the table, I'm ready to do my first test fit. What I'm going to do is the equivalent of a dry fit, just to see how close we have this, and if it's, once it's up in its dihedral angle, you can see we've got a relatively nice fit there. Now also, do we have the angle that we want? They want to make sure these are on center. We got to go over and look at the drawing and see if we have the angle. But it's that fit. That fit is real nice. I'll be able to live with that. And when we do the final lineup, of course, I'm trying that we want it right on center, front and back. So that's, I guess that tool worked okay. Again, the trick with all these things is to make them inexpensive, quick, easy, cheap, and that they work. Now I'm trying to picture what that dihedral angle is going to look like. Again, that's why I like to have concept drawings. I like to take a look at it. Now when I did a final thing is I laid the wing right on top here. I noticed I didn't have enough dihedral, and I said, well, what could I have possibly done wrong? And the difference is an inch from here to here, and an inch here. So what I thought of originally doing, I put each one up a half inch, thinking, well, a half inch would be an inch. Nope. Each one has to go up an inch, so I got to redo the whole thing, and I'll do it off camera. But instead of having ½ inch under the side, see, that's the kind of thing you work late at night, you tend to make a mistake, and that's why having that concept drawing is so important. So I'm putting an extra ½ inch. It'll have 1 inch under each tip. Basically redundant thing, do it over again. But having a concept drawing, if I didn't have the concept drawing, I would look and say, yeah, it has a little dihedral, yeah. But as soon as I laid it up in this dimension, I noticed it obviously was wrong, and it helped me make a correction before I went to the next step. So you can see we're out sanding away right now. We'll come back to this when we make our correction. A lot of people think, well, why don't you just edit out all the mistakes? But yeah, you know, then people wouldn't get the idea that we were dealing in reality here. This is how it really happens, and how you think in your mind, you leave one step out, and that's why having those drawings is so important. Okay, now on dry fitness, I'm looking at the top edge of the wing, and yes, it was an inch, not a ½ inch. Anyway, that is one of the defining, as I've laid it down here, the defining features of the model. So you can see how much of a dihedral break is in. I just have it taped together now. The next step in this, and of course we're going to line that up when we glue it, the next step in this is going to be to make the clearance for the belt crank. Now we got what I hope is going to be both of the angles set now. You can get an idea just how much that angle is. But, you know, working late like this, working late at night, these are the kind of mistakes you make. But we're going to come back tomorrow and work on that belt crank. I just feel like I ducked one bullet tonight, won't duck the belt crank. It's a good time to quit while I'm a foam wing or something. Hey, John did a nice job cutting these wings. They are just really nice. And every day, every night when we put this away, it just becomes more and more like the drawings that Dave made. It's starting to look like an airplane here. Now today what I want to do is, I have the belt crank that we made up on the first video here with the lead outs that are 1,000 feet long. In the outboard half of this panel, I want to lay out exactly the spot and make the cutouts. Now this is not going to go on center because of the dihedral. This is going to wind up, normally on a foam wing you try to put it right in the middle. We're going to try to put it high enough in the wing that when we take into account that dihedral angle, the lead outs will have a straight shot right through the hole in the wing. Now this is what we're trying to do, is get the belt crank mounted. I'm exaggerating this, of course, because if we were to mount it in the middle, these lead outs would come out somewhere where we don't want them. And this is one of the things Dave has really carefully calculated out. So the objective would be to get it as high here. Now it serves two purposes too, because what will happen is, with the belt crank mounted high, and Noel Drindak proved this already, you get a more linear throw to the control horn. The lower, if you were to make the belt crank here, this angle that the push rod rides on makes for a non-linear control input. The higher the belt crank, so actually this is like a free gain that we're getting here, not that this would matter, but having a belt crank as high in that center section as possible is going to give us a more linear, we hope anyway. Again, everything with this plane is a maybe so far. This is a look at what our wingtip ultimately will look like. Is the lead outs are going to be exiting below. This is where they normally would exit. They'll be exiting below, so what we're trying to do is get the belt crank as high and the lead outs as low as possible. And again, a lot of that was a careful calculation when Dave made the drawing, getting all these angles right, that you could have a straight run with the wires. Well, one of the things we want to start thinking about today, Warren Walker is making us up these horns that have a counterwound spring. These are just test units, we don't know. because we need flex joints. Actually, we could probably get away with using them at 3 points here, but if all was equal, this would be the right way to do it. And we'll have to see when they come in. They should be in later this week. And there's another scenario. There's another little flap that goes from the nacelle to where the main flap is. I don't know how we're going to deal with that yet. But again, this is the fun of making these things. All right. So the first thing is, using the traditional way we would mount it in a foam wing. We want to get that bell crank set in there. Side benefit of having this dihedral angle on 90 degrees is if we had this on an angle, what would happen is when we set our bell crank in, we wouldn't have a reference. We know right now when we line this up, taking into account the dihedral angle, that we're going to have hopefully a good reference. Because if this bell crank was on an angle, it would put an unusual strain on this bushing. It would want to push the bushing down or pull the bushing up. So it is to our benefit to have this angle exactly 90 degrees to where the plane is going to be flying. Now the first thing, like with any foam wing, is I want to notch this in exactly half of the amount of the throw. The throw is 13/16, so roughly 3/8 of an inch. I want to notch this bell crank so that when the control is at half throw, when it's at half throw, the push rod is right on the middle of the wing. Not at neutral, but at half throw. And that little notch will be 3/8 of an inch. And that would apply if you were building a Cardinal or whatever, any model that's going to use a reverse bell crank, where the up line is forward. First thing is to measure off exactly the dimension we want, top and bottom. Again, this would be the same thing no matter what foam wing you were joining. At least this is the way I've done it over the years, and it's worked relatively well. You can see what I've done carefully is with a saw blade. In fact, I'm going in almost the depth. I don't want to go too far. Almost the depth of the saw blade. A zone of blade. The other side makes a nice, the back side just makes a handy tool, because what I want to do, I just want to carefully cut that notch. Now the next step is, as I put the bell crank in, I got to cut some of the foam away on this side to get some clearance, just enough clearance so I have full movement of the bell crank. You can see what I've done is just, I don't want to take any more foam away than I have to. That should give me full travel to lead out to not hitting the top of the wing. Now I need to cut just enough, and I don't want to cut any more than I have to, just enough of an opening, about half of the width of the push rod. And any other foam, of course, that seems to get in the way here. What's nice is I can just unplug this and plug it in. I can raise it up, lower it until I get a final set on it. Yeah, know the 2 points at which it's going to take away. I just need to take about roughly half to start with. And what I did, I marked the spot, just put a mark on, so I know this is roughly where I want to start removing that material. We may have to open it up more, but I certainly don't want to take a big, I think many times even I do, they take a big chunk out of this, because this middle of the wing has to be a lot stronger than a normal wing because it's supporting the two engines, among other things. Easy way to get the last little bit out of here and keep edges relatively straight. I like to keep the opening as small as possible until we get the horn on, because we don't know what that geometry is going to be like. But that should give us enough clearance in this side now that we can just drop the bell crank and that whole assembly right in and out. Next step is to transpose this push rod opening out into this side so we have the same, roughly the same cut that we have on that side in this side. And also I need to transpose this little cutout, because as the bell crank moves it's going to want to hit the spar on this side. So this little cutout and this little cutout, and we should be ready to do a final dry fit on the wing. Now I have that little piece trimmed away. Again, I don't want to, what would happen if you didn't do this, the foam would eventually get chopped away, but by then it's all over the middle of the plane. Neater if you can take it away right now. Now we're obviously going to have to take a little more away when we do a final joint. We have a rough hole cut, and we can trim that away. Next step on this is I want to get just a piece of scrap 1/8" balsa and some epoxy, some 5-minute epoxy that will just hold this in position. It's going to do nothing but just be almost like a tack glue to hold this in position, so this rod can't walk up and down. And we could set, if we were doing a traditional plane, we'd want this in the middle. In this case, we want it up high like this. And what that does, I'll just pin that in there and let it lock that in. And once that's drying, I can get ready to join the wings. Keep in mind, I'll put this on. I just need to have a piece of scrap, but I want it to be a tight fit. See how it just presses that in position? And epoxy. And for the glue to dry up, the epoxy, I can fine tune this, make sure it's parallel in every dimension. What I want to make sure is that I don't have it in one way or another uneven. And from this side, of course the airfoil is different, but that I'm true with the center line. I don't want to have it up or down. Alright, once that dries, then we're just going to come back to this, trim all this off, and we'll be ready to join the wing. We could also trim some of this extra foam off in there. It's just going along for the ride. One final check to make sure everything's on center. The glue is dry. We haven't built in any kind of an angle. That piece is sanded in, and of course I want to make sure I keep this parallel. I've already checked to make sure I don't have any interference anywhere on the bell crank movement. And I had to cut a little extra foam away in the back there, so what I'll do is I'll cut the same amount. I'm trying to picture in my mind how much it is. I'm probably going to cut quite a bit out of the other side. And I'll do that before I even do my dry fit. I'll just extend this back in a little bit. I took even a little bit extra out just to make sure that doesn't hold anything. In fact, the compressibility of the wing, the mount actually works as something that'll help act as a spar, that bell crank mount. Look who's here to help me. Isn't that cute? Hey, there's a builder to model rule involved here. And if you start working on this, you're going to go to John Duncan's and live up there. You're going. Next things, before I even join this together, I'm going to clip everything but about 1/8 inch of wire off each side, just because it'll be in my way for the time I'm working on it. And when this is all done, I'll make a little support up here. Of course, because this is going to get glassed, and there'll be a support inside to what will amount to be the bottom fuselage side, and up here maybe some kind of a little, have to invent that yet, a little triangle piece, but so far so good. Now the one thing I want to make sure that I don't make this too short. In fact, I'll leave maybe 1/4 inch out of this for now. Also another thing, get rid of that edge. That edge, for all the time you're sanding and doing all the work, it's like a razor blade if you don't clean it up. Now, the next thing on this is going to be to dry fit this in position. You can see we've got the wire trimmed. To dry fit this even, what I want to do is I want to grease the control system This is motorcycle chain oil. And what it is, it goes on like a liquid. But when this dries, it turns into wheel bearing grease. Any place that sells motorcycles will sell this, and they even make better stuff than this now. This can is a couple of years old. They make some stuff that's even better, some real high-tech synthetic stuff. But this is what I've had this same can for 10. Shows you how much motorcycle riding I do. I think Bobby Hunt's got me beat there. Anyway, we'll let that free up. It looks like a liquid, but when that dries, that becomes wheel bearing grease. Now once, of course, I have the lead outs in, I want to just make sure I've got this, that I can get a test fit. And what I'll do, I'll use tape to make sure I don't have any part of this, and some real slow drying epoxy. These great little flux brushes, they're about half the size of a regular flux brush. They'll be perfect for this job. I'm going to make the joint with slow drying epoxy. That'll give me a nice window. Again, when this epoxy gets out of code, it crystallizes, all these commercial epoxies, and then the drying, instead of drying in 45 minutes or an hour, in fact, maybe what we'll do is, because of this, we'll put this aside to dry overnight. I love when you try to get the last couple of drops out of something, out of shampoo or something. Anyway, that'll give us 45 minutes to adjust this and line it up, make sure the center lines are on center. Here we go. The little flux brush will be a big help here. Now I've done a little dry fit, made sure there was no interference on the obvious things. Famous last words, I know. I can hear the audience now. Anyway, little hot news here. Ken Clapson, one of our really good friends from Canada, is working on a 40 size profile tsunami. Going to have Elliot Scott help him with the plans, which will be nice. Add another little plan to our little Air Force. Now, once that's mixed up, now I have to be real careful, because one of the things I don't want to do, I don't want to get any glue on a bell crank or lead outs, and I only want to get it on the wood. I'm not real interested in gluing the foam together. I don't think it's going to be real productive, but I'll go out and I'll do a lot of this off camera, because I just wanted to show the technique. Just have it up on the edges. It does not need to be on the foam. You just need to do all the edges. Now what I'm going to do is do just the edges on both sides and then tape it together. And I can squeeze out all the extra epoxy, make sure the two center lines are on center. So you always try to plan what I'm going to be doing in the next 5 or 10 minutes. Because I've got 15 minutes. And by the way, these little brushes work great, Warren. They come from McMaster Car. Now what I like to do is just make sure I get a good glue footprint here. And you can see the little strings of epoxy before I do the taping. And this, needless to say, is something we have about 45 minutes now to line this up. As soon as I flip this over, it's going to separate. Oh, I lied. And I'm not really looking for the skins to be at within a millionth of an inch. I can do a little final adjusting on that, but I want the center lines to be right on. It's the center lines that are critical right now. Now what I do is I put the tape on one side, get it attached maybe to 6 or 8 inches, and just put a little bit of tension on it so it's like a rubber band. And now I can work this, and I can work my center lines. It's got to come up. And it does take, you definitely don't ever do this with 5 minutes. You'll be really unhappy. Done that, in there, done that. Okay, now this side I want to put a little tension on, just a little. But I'm monitoring it every step of the way. I'm keeping my center lines in order. Now I'll flip it over and do this side. It's harder to keep with the dihedral. It's harder to keep this even. Put a little bit of tension, but it's only got to hold it maybe for an hour, 45 minutes, an hour. And get rid of some of the epoxy that oozes up. And yes, that is why they make pants, so you can wipe your hands off conveniently. Okay, now I see I got a little bit of epoxy oozing up here. But basically what I'm really concerned with most of all is keeping everything on center. And you can always use a couple of pins to hold the center lines while this is drying. And I'm going to put some more tape on this. Each time I do, the tension of the tape presses out more of the epoxy and makes for a little bit nicer joint. Now once we get everything lined up, the last little thing is just putting strips of tape, tip to tip, using them as rubber bands, put a little bit of tension. Now what you could do if you're doing a traditional foam wing, you can use, if your joint isn't exactly perfect and the wing starts to have dihedral, you can put more tape on that side and sight down the leading and trailing edges. That's a good way if you just need to take a little bit, and I mean a little bit. You wouldn't want to be taking an inch out that way, but if you had a 1/64 of an inch off or something, you probably could do that. But every step of the way here, I'm monitoring, because what I'm going to do is put this aside to dry overnight. This is slow drying epoxy. I'm going to put this piece, I'll finish taping the top of the wing. I want this to dry overnight. Make sure every step of the way, working off those center lines. Now I feel best if I let this kind of a joint dry overnight before I work on it again. And I have other work to do here. In fact, I'm going to try to do a little bit of laying out the blocks for the fuselage. This is part of the time management that I try to use, is always have a secondary project. And in this case, what we're going to try to do is lay out the blocks for the fuselage in a little bit of time we have left. When Elliot Scott was here on his last visit, and we really had a great time, he brought me some blocks of wood that were 4 inches. Now, the problem is this fuselage is 4 1/16. So, even though we tried, that was a nice try, but no cigar. That's not going to work. Back here, it's still a good 1/16 of an inch. It's not even, it's more, it's 1/8 of an inch. So I'm not going to be able to use these in the spots that I originally thought I would. I may be able to use, nope, see. So what I'm going to do, I came up with a little technique that may work. I'm not sure if this is going to, what is he eating? Hey! And that's Dremel tools. What I thought I'd do is I'd take and cut half of each block out of a block. And the advantage to that would be that then I would have a center line down the middle that I could reference off when I go to line things up. I wouldn't want, if you're going to have a center line in a block, you sure don't want it anywhere but right in the middle, so that the curve, it's not in the middle of a curve where you'd never get it out. So I think that might work. Again, I wish this was a less of a decision. In fact, I don't even think we can use it up in the front here by the nose. Nope. The fuselage is just a little bigger than these blocks. So we're going to have to do that thing where we split the blocks, but we'll split them right on the center line. And we have enough blocks now that we should be able to do this very nicely. There's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 individual, plus the nose. 11 blocks that eventually are going to get carved up. So I'm going to start carving these up. Back will be the most critical. I want the lightest piece of wood as far back in the fuselage as I can get. So I've taken the lightest of the blocks. What I'm going to do is split it, pretty much the same way we made the crutch, because it's only right up here that it's about 1/8 of an inch or so too big. But by using 2 different pieces, I can get them both out of the same block, and the only downside will be that I'll need a joint. Now before I actually make the joint, I'll rub it on the sandpaper so I have a nice clean joint, because I'll be carving through it, and halfway through it I don't want it to be that there's a spot where there isn't any glue. Now with these blocks, this back block, of course I want to get this angle in it. I can do that on a belt sander too. Get some of these angles roughed in before I even tack glue in place.
So I'm trying to I'm taking a little bit out of time. I should have that pretty accurate to the fuselage side.
Now I've left it just a little bit, like everything, always a little bit oversized. I'm going to rough out all these blocks, and each one of them will have, this one I already made up, that joint running right down the center, and I can keep that as my center line. May or may not serve some useful purpose in this, once I lay out and get all these blocks in place. Now this one is tacked on, and I was not able to get it all the way to the end. I'll put a little filler piece. I didn't want to waste that piece of wood since this was the lightest piece of wood. Now the next thing is I want to lay out this block, and this block will more or less just be a filler block. I don't even know if we're going to use it, but I need to reverse this angle, get this piece in here, and have this at a 90 degree. And this one for sure I'll have the center down because this is where the fuselage is the widest. Next piece, I have the joint already done. First thing I'll do is grind in that angle so we have a nice, relatively nice fit. Even though we're going to put a former at each end, I'd like to have that angle, well, relatively close anyway. And notice I made everything oversized by quite a bit because once I start grinding that, getting this angle at 90 degrees, I can do that with the saw. Now the next thing is just to get a triangle in here, pick up this edge, and make a 90 degree cut. Maybe leave it even just a bit oversized, because we don't know if, I don't know at this point in time if I'm going to use this piece at the bottom of the fuselage or not. Then one by one I'm working my way. Notice I'm doing the bottom first because if I'm going to, you're going to mess anything up or whatever, let it be on the bottom. I'll do the front block next, and then start at the top and work toward the front. Do the rest of these off camera. They're all redundant. I want to get all the block fits on the bottom, at least where all these break points are, to be identical. I get all the bottom blocks tacked on. I wasn't able to keep the center line the way, trying to use up the smaller pieces of these blocks. A lot of times it just doesn't work out, but I have the joints as accurate as I can. I need to lay out the top, and that'll be the most significant one, is the one that goes along the whole top, and that's where I'm glad I have these 41-inch blocks. Those blocks are presenting the biggest challenge of all, and I've got to make it up out of 4 individual pieces and get the angles right. And I'm making it plenty oversized so I can curve all these in, and then I'm going to make one small block on the bottom. None of these blocks up in the front are really, I'm not using up the good wood. This plane is definitely going to need some nose weight, so may as well use up these heavy blocks. You see, it was comprised of 4 different blocks, and I've got to get the angle in there now. That angle is not right. But this was, I'm leaving a lot, actually I'm leaving a lot of extra wood because I don't know what that final shape is going to be. I'd rather have it a little big and I can work it in when I start doing the sculpting on this. Still not the right angle. See what, I can take a little bit off at a time with that belt sander until I get that angle accurate. And the last block we need to fit. I need to get a block. We'll make one up from laminates. It's going to have an angle on it. And I've got, well, you don't see it on the tape, but this took quite a long time to fit these blocks up, the better part of a work session. I get that little block in the front, and that's probably all we're going to get done today. Get some idea of how many blocks I had to chop up to do this. This might be the biggest single carbon job that I've ever had to do. Guess we're going to find out by the end of this week. some real tough decisions to make here. I cut up a bunch of blocks and I was not happy because the joints, when I was doing 1.5-inch blocks and various, the joints were a problem. Now I'm just fitting this up. This is going to be way oversized and I'll have to try to get some of this off. But basically, the nicer I can make these fits now, it'll just make it better when I actually go to pull everything apart after it's hollowed. Again, just a little bit of fit. These don't have to be perfect right now, but the better they are, that's an unusual concept. The better they are, the better they are. This actually took a whole lot longer. Now you can see how close I have this. The fit in there is a lot more like what I'm going to be willing to live with. Now I can trim this off. Well, that's definitely a good day's work getting all those blocks. I just laid the body of Miss Ashley out here to give everybody some idea of just how big this plane really is. It doesn't look that big. Look it up here and just look it down to poor old Miss Ashley. Looks like a chick, so to speak. Anyway, next time we get to work on this, it's going to be carve. I want to rough out the blocks anyway. The wing is drying, and that's a good thing. Even if I let that dry an extra day or so, that'll just ensure that there'll be no chance that joint is going to be soft when we come back and work on it. This is what's left of all our blocks. To get that thing rolling. I'm amazed. As I'm cleaning up the shop here tonight, I'm amazed how long that took. That much longer than I thought it would. And I'm sure this is the most ambitious carving job I've ever done, period. So it may take extra time. When we're not building to a time standard, we're building to a quality standard, which means it'll probably take twice the amount of time I thought it would. And these are all good blocks, too. None of this is scrap. These are not ones I want to make. This is the stuff Elliot brought over. You can see it's even a different color. It's lighter than. This is the wood he brought from England. Look at the difference. Anyway, it's been a long day. I'm be thinking about how I'm going to carve this up tomorrow. I only have a little bit of time tonight, but I thought this would be a great idea. I would get down here and try to rough out the block as much as possible. I was thinking about this, and this is going to be a big job. So rather than try to do it in one or two little pieces or something, and it's really getting cold out there. I can't tell you how happy I am that I got some of that clear on Miss Ashley. There'll be no painting in this temperature. Anyway, the first step, new blades, of course, goes without saying. I want to lay out tape everywhere that there's going to be an edge where I'm going to carve into. And this is just like a safety, is to have that up there so when I'm working the knife, same as doing the wing, I don't wind up with a problem. The objective here is to make the shells and everything, when they're all done, a little less than an 1/8 inch, but I don't want to make them a 1/64 of an inch. I don't want to have big soft spots where when you touch this and squeeze it, it's a problem. So, having said that, let's get a new blade and a knife. The problem is, a lot of people, put something on this blade. This was a brand new blade 5 minutes ago. A lot of people don't understand that it's really important to keep changing the blade. Anytime you want to know if your blade is sharp, just take your fingernail and shave it. And if it doesn't shave up nice clean pieces of fingernail, it's for all purposes dull. And what happens when you have a dull blade, you keep crushing the wood and munching it and squishing it and everything. Excellent idea, even if you're really highly skilled at carving, because every once in a while, the wood all being the same color, you don't really notice how thin it's getting, where you can see from the tape if you get near or getting close, and you can put the brakes on. Very, very cheap insurance to have this tape on. Anywhere where a carved block is going to meet a shell, we'll have tape. For now, anyway. When we're all done and everything is glued together permanently, then we're not going to need that, and we're just going to dress off all the edges. But this is a big help, a good tip. So without further ado, and see, the problem is I know I'm not going to get this done in a very short amount of time, so I'm just going to pick little things like tonight, if I can, in maybe an hour, hour and a half, is to get as much of the radius as put in the block. I'm not going to try to finalize anything. I want to get everything roughed out. Because then in this area here, I have to cut in this canopy. I have to get that angle right. And again, I'm working off the drawings. And because this is such a large piece, this is a physically at least twice the size of a normal sunship. Twice as much. There's twice as much wood in it anyway. Sense, I guess, to start. The first thing, I'll work on the back here, to get this level with the blue tape, or within, say, a pen line of the blue tape. And if I view it from this angle, I can get even amounts of this wood off. Again, for some reason, see, I just went into that there because I'm not. The reason I always start on the bottom of things is it takes me a little time to get my rhythm going, especially for carving. Knife, never at a 90-degree angle, always at a 45-degree angle. As soon as it starts not cutting a nice piece like this off, get a new blade in. So if we get this view, again, we don't have a lot of time here, but we're going to be doing this in several sessions. But the main thing is just to get it started. And I'll go around the whole perimeter and get this, with this piece now, rather than being like this, if you can see how that is, we're right, in fact I already went into the tape already a little bit. That would be step one. The thing that I always have trouble with, and the reason I put all these formas in here, is because when you're carving something, you have to squeeze it and hold it, and so many things are happening. It's easy to put your finger through it. So having all those formas in there, but this part is so big, it's like trying to hold a watermelon. I'm trying to cradle it and, hey! I'm trying to cradle it. We may have to put the pad on the table here. I didn't realize this, and I'm going into that blue tape on a regular basis. So I know I don't have my technique moving yet, so I'll stick to the bottom and get all the bottom done. In case I have to thin it, it'll be at the bottom rather than the top. Because I'd like the top to have that really nice flowing curve. The way you can get yourself in trouble is when you have a big carving job, it's like going on a long trip. You get ready for a long trip, and you do it one day at a time. You don't get bored a half hour into it and try to finish it. This is going to be very time consuming. You probably won't see on the video how many hours went into this, but certainly going to be a lot. So get some quality video entertainment on, like Wings or something, and or heaven forbid a windy video. Anyway, but you get that going and it makes the job a little easier. Now you can see because I've just started this a little while, I've already gone into the tape a few spots, so that saves me just big gouges that normally would have been out of that wood by now. And I can assume when I get up by the nose here, this is going to be real time consuming. Because this is taking time just to do the easy parts here. But it'll be worth it. When this is done, this is going to be some special piece of artwork, I hope. For sure, the hardest part of this whole thing is getting this nose section roughed out. It's such an unusual shape. And with all these glue joints, I want to go nice and slow, even with the plane on a 45-degree angle. I'm trying to get everything squared up first so I can look at the overall shape. And that's a good thing to do whether you're building, a typical, any stunt ship where you have carving to do. Now, you may be thinking, well, why don't you just mold blocks? Yeah, well, making the molds for this complex of a project would be very time consuming. And I'm not sure there would be much of a saving when I'm done with these blocks. They'll be relatively hollow, whether they like it or not. Once I get this contour in here, now that's the next one to work on, and get this round, it's going to hopefully start to look like something like what we had in mind. I've got all of the flat angles flat now. But that front, that's going to take that's like carving a cowling. I really enjoy is taking my best 4 to 6 pound blocks and turning them into garbage. But sometimes curves like that
I'm going to have to go to the drawing and see if I've got that profile the way I want it. But the more roughing I can do at the grindstone, the better it'll be. The old sander. Start to get that to come together.
What the actual shape that I'm working toward is, just going to have to carve it in a little by little. Into it, and I can see I've already got this nose angle wrong, and I've made about 12 corrections to it already. Before I work up into the cockpit area, I'm working from the side view from Dave's drawing to get it as close to the side view as possible. Even though we've thinned this a bit, the side view shouldn't change at all. It's a shape that looks real easy to carve, but when you start carving it, you realize a lot of angles and things that go up into it. This is where it really gets challenging. I had to put a little filler block in here. Now, whenever you're carving this kind of an angle, you've got to kind of look from the top and make a score, and then work your way into that score, especially on like a cardinal top or a top that has a defined line. And then I'll make me a little piece of paper to see that, kind of a template to see that I've got it going. But all cuts go into the line. These are all rough cuts anyway, and before we're not going to do any sanding on this. This is going to be all rough cuts. Actually, it's starting to look like the spruce goose or something. I don't know. And the last thing I'm going to get done tonight is I just want to rough in this curve. And with the plane, just get this angle, just so I can get a feel for if this is starting to look like what I want it to look like. We know we have many days of carving and sanding and hollowing and whatever, but roughing it out. Once this part is done, we can really start to see. And from this point on, I'll be doing most of the feeling with my hand. We can see if we're going in the right direction here. In fact, if you look down from the front, I don't know if we've got that B25. Well, this is probably the end of what we're going to get done tonight. We'll pick this up tomorrow. I'm going to clean the table. Just leave it. Come back and work on it tomorrow in the morning. Well, you hardly see it, but this was about 2 hours of carving early this morning, and I just left the mess on the table. The bottom is done now. Roughed in anyway. When I get back to the shop later, I'm going to start the sanding operation. I was hoping I could do some of this outside because there's so much dust, and I really don't like the dust in the shop, but it's just hard to believe how much carving this was altogether. But it's got the rough shape in it now, and from this point on, it's usually a little bit easier. Just make up some rough sanding blocks, and if possible, if we can get outside, I don't know what the weather's going to be like later, get some of this done, or the worst that can happen, we'll get over by a vacuum bench. But this is what's, the last couple of days, it's just, this is what the shop looks like, this is what everything looks like. But it's worth it. It's starting to have that B25 look. I don't know why, but it looks more like the spruce goose than anything else. Anyway, coming along. One day at a time. This is not going to be done in one day, that's for sure. But Wendy, Rome wasn't built in a day. Good pizza takes time in the oven. Yeah, we'll pick this up again.
They completed this in record time.
Now, looking at the documentation of what I'm trying to finalize in my mind here, I'm going to start sanding from this point on and maybe just a little more carving. I've got the shape roughed out in the past couple of days, and I want to get a real feel for what that nose really looks like. One of the things, there are so many variations of gun arrangements and glass nose, and I kind of favor the version with the glass in the nose. I just think that'd be a little more attractive. But of course, we do have the choice of several different gun arrangements. Then this nose and cabin, and it's this area right here that I'm concentrating on. I want to get that right. And I want to estimate just how much of a curve. Now, this is not a round fuselage top. It goes up and has a kind of a flat on top. So I want to take that into account too when I do the carving. What I usually do is I leave the books open right on the work table so I can kind of see this curve here. The top is a curve. It's not a straight line. It's a curve. And then down here, there's no straight line on it, and then down here it kind of flattens out. But I had originally carved this with a straight line, and I think I couldn't figure out what was wrong. It needs to have that curve. It's these things that define this, the kind of a straight edge here, almost a direct curve. Now I need to look at this from the top view. Unfortunately, Dave has this all drawn up very accurately, but the most significant thing that I missed on the initial carving was that this has a curve to it. I'm going to have to sand or just do a little more carving. And this is not every part of this nose section is a curve. In the bottom view I can see how much there's definitely a flat in the middle of the fuselage, and it has a definable break. So I'm guessing right here, it's going to have a curve, a flat, and a curve. So that's significant to know that when I start the final sanding and shaping here. And it's a good thing to just look these books over while I have my coffee here before I start whacking away at this. In the top view, what's significant here is that these have a curve, a flat, and how wide the fuselage is. So normally a stunt ship would taper down and would have been nothing. That fuselage stays wide right to the very end. I need to keep that in mind when I'm doing this. And I do most of it with my fingertips. I just do the carving and feel it, look at a picture, feel it. The final little bit, that's the only way I know that you can get it done quickly. And what's most important here is to keep in mind where that whole front is a continuous curve. There's almost no spot on there that you'd have a flat surface. There's only one little, on the one that has one machine gun in the front, has one little flat spot in the front. This is one of our better views of just what is just that little, I guess it's a relatively flat spot, but I really have to concentrate on the fact that this is so curved, this whole front. There's no, even when you look through the windows, no flat spot on there at all, and how the windscreen blends in. These are all defining features, and that's why having these pictures is going to be such a big help while I do this final sanding and carving. Here's a good one that shows that whole front area. And it's this area here where it comes down into the windshield area that's significant too. We're real lucky to have plenty of pictures, and these I'm sure every one of them will be put to good use. So ladies out on the table, let's get some sanding blocks made up and get cracking. I even pick up the knife or the plane or the sanding blocks. Again, I always try to familiarize myself with what is the real shape. I try to lay that block over it, work off Dave's drawing to get the outlines, but then the curves can come from any number of different drawings that we have, and Bruce Hunt has sent us so much stuff here. We really do have a good knowledge of what this really looks like. And it's the significant thing here is that there aren't any flat, from this point on, this is all curves. And I think that's what's going to help us finalize what this curved area, that it really is all curves. And no matter how you look at it, there just aren't any straight lines. It's all curves. You can see how close we have roughed it out, but see, it's that top curve. See, I don't have enough curve in the windshield yet to match the drawing, and I have too much of a, well, we don't know for sure too much, because once you start sanding it away. So what I'm going to do now, before I go to the next step, because I won't be using much of the blade anymore. I'm going to pull off all the tape, and get a sanding block, and remembering that there's kind of a flat in the top of this, and that everything from here forward just gets curved. Everything is a constant curve. Take the blue tape off. I've just done a rough sanding with some, I think this is 80 grit, I'm not sure. It's 100 on a block, just to get these curves in. I want to get the curve in, and I lay this over 2 pads, so I'm not chopping up the front of it. You can just see, because this, by the way, this balsa that Elliot got from England is just super. I'm going to make him my balsa distributor of choice. You can see how that powders right off. Getting that curve, and is just a slight flat in the middle. That's a real, a difficult shape to really get in your mind. Then when I'm all done, I get that middle flat that's on there. Again, we're going to be doing this for the better part of the day, just sanding and grinding away. It's impossible to do it outside. It's 10 degrees out there, so you can see how nice that wood is just powdering right off. This little fixture out of some rolled up towels, so that the vacuum bench is right in the middle. And when I'm working in, because I have hours of sanding to do, whoop, as I said, it rolls off the table and falls over. Because I have quite a bit of time to spend here, I want to do it piece by piece. I don't want to try to rush it through. Getting these compound curves, even if it takes me a whole session, I want to have that part of it before I move on. I want to have everything roughed into the rough shape that I'm really looking for. To be the hardest of all the curves to work in, and I've really spent a lot of time just trying to get this canopy area. You know, I have to always keep in mind this is not a scale model, so I'm allowed to deviate some. We've thinned the fuselage some, but to try to get the look without having the downside of it. And it's hard to picture. This comes down and then straight. Again, boy, there's no substitute for these sanding blocks that have the little curve. Bob Martens made these in 95, 96 when we were doing a Spitfire project. Again, I always try to feel with my hand to see, and then get the curve. And then to get it symmetrical, that's the real challenge. The trick, of course, is look right from the top. Now I have a couple of spots I'm going to fill these in. It's the reason I'm not worried about these little chips and dings, because these blocks aren't permanently hollowed. I mean, permanently attached. When they're hollowed, then I can fill. I can either put little blocks of wood in there, or air epoxy light, or whatever. And looking from the top to see that the curve is kind of symmetrical. Again, the last little thing I need to get, and see how the undercut of the block works right into that corner before I take these blocks apart. We've only got a few spots we need to repair, but we'll repair them this is so important, is to get, the reason I'm not using a big block is I don't want to get a flat line in there, but I want to get that clearly defined angle. And even if this was an ordinary traditional stun chip, you'd want that, I'd want that even on a cardinal. I want that angle in there. That's why making up these sanding blocks is such a real important thing. Now I can work this area. Again, I'm never out of sight of the books that I have available, and the more you have, the better, or the more video or books or whatever we have, certainly to our advantage. Now, if I were to do this over, I can see one of the things that might be an improvement was I should have continued this block all the way up and made this one total block. The reason is that this is getting kind of thin here, and I'll have to put a little patch inside. If that would have been a better choice, maybe Dave can adjust the plans when he draws them that way, just so we have all the updates. And having the adjustments on the plans is so important, because if you go to build a second like we did on the Spitfires or a third model, you have all the corrections and you just go right through it. If you don't have the corrections drawn, then you're adding extra building time for nothing. It's this area here that's going to get a little thin, but we can probably put a little triangle piece inside. See, now I've purposely left extra wood on there, all these surfaces. This is not the final joint here, for instance. I want plenty of wood there because when I get this permanently together, or the parts of it that'll be shells and take apart, then I can get a final cut. If that's already paper thin, it can get to be a problem. Once it's all together permanently, this little spot on the top of the cockpit will fill out with Aeropoxy or CA or something. We got a spot there, but other than that, it's a pretty clean piece. Now, while we're taking a little break here, Mike dropped off the cowling. This is one we made, I think, on a previous video, or not long ago. And it fits his rebuild, and we've been following that rebuild. Where's the wing? Miss Ashley rebuild. And if it warms up later today, I'll go spray some blue on this for him, a couple of coats of blue, but we've just been in some unsprayable weather here. But I'm kind of glad because it's given me more time to focus on this project. Where normally I wouldn't be spending this much time, I'd be spending half on the other project. Well, the weather kind of determines a lot of what happens here in the Northeast. We're pretty close to what Dave had envisioned here. Not far from it anyway. It looks like we could taper the back maybe a 1/8 of an inch more. Remember, we made some changes to this whole location, so I would rather be a little thick than thin here. I can always carve a little more away. Now the next step on this is going to be to pull all these blocks off and one by one hollow them out as much as we intend to. That I can do probably in one of my short sessions. We won't have to reserve a whole day for that. And this is the part every night that I like to review, just look at what we've accomplished in the last couple of days. I really think we're well on the way to some successful modeling here. This is the first time that I've stood back from it and really realized just how much like a B-25 it's starting to look. So thanks for joining us. We're at the end of this tape. Please share the tapes with all your friends. Share the fun. Project has really been a lot of fun so far. Really given me a lot to think about, a lot to dream about. And as George Venturini always says, dreams are free. We'll see you on the next tape. I often wonder just what you possibly could do with your life to have more fun than we have in the world of control line stunt. And we're going to see this guy put back in one piece real soon, back in the air in the spring. And most of all, I hope you really enjoy sharing this little part of our life that we all so much enjoy, the world of building and flying these control line stunt models. See you on the next tape.